Okay, today we're going to be learning how to classify triangles by angle measure and side length. This is our lesson 4-1 in our geometry book. We start by looking at classifying triangles by angle measure. Now, triangles can be acute triangles. Those would be the ones with 3 acute angles. Notice every angle is less than a corner. If it's a right triangle, there's one 90-degree angle, so you could put a corner in there and see that the angle is 90 degrees. The third way we could look at it is if one of the angles in the triangle was more than 90 degrees, it made more than a corner, then it would be an obtuse triangle. Notice if you put your corner in here, there's a little bit more to the angle. And finally, if all of the angles are the same, it's an equiangular triangle. And a little hint on that one, if it's equiangular, then since every triangle has 180 degrees for the sum of their angles, each angle is 60 degrees. That's angle measure. Now, if we wanted to classify our triangles by side length, we could look at a triangle and maybe all the sides were the same, and we would know that by these tick marks. Since each side has a tick mark, we know they're all the same length, so that's 3 congruent sides, and we call it equilateral, equal sides. If there's 2 of the sides are the same length, then we call it an isosceles triangle. It has at least 2 congruent sides. Notice there's 2 tick marks here and 2 tick marks here, and that shows that this side and this side are the same. Now, if no sides are the same length, they're all different lengths, then we call it a scalene triangle. It's got no congruent sides. A quick note, since isosceles triangles have at least 2 congruent sides, they might have 3 congruent sides. So if it's an equilateral triangle, it also fits into the category of isosceles, but it's specialized as equilateral triangle. But isosceles triangles aren't all equilateral. Equilateral triangles are all isosceles. Now, let's look at how we can use these classifications or these definitions to classify some triangles. Let's look at this picture here. Remember that acute triangles, we're going to classify by angle measure first. Remember, if they're acute, all 3 angles are less than 90. If it's obtuse, one of the angles is greater than 90. 2 couldn't be greater than 90 because there's only 180 degrees in an entire triangle. And if it's a right triangle, then one angle equals 90. Remember also equiangular, equal angles. That's what that means. All the 3 angles, they're 60 degrees each because 180 divided by 3 equals 60 degrees. So let's look at our picture up here. And if we wanted to classify angle EFH, first we kind of trace it out and we look at it. Well, this is 30 and this is 30. We don't know this angle. We suspect it's more than 90 because it looks like more than a corner, but we've been told never to assume. So let's figure it out. I know these 2 angles form a linear pair. So I can take 180 minus 60, minus this 60 degrees on this straight line, and get 120 degrees for this angle. I also could have said 180 minus the sum of these 2 angles, 180 minus 30 plus 30 is 60. And that would have gotten me the same 120. So that's a 120 degree angle. So I know this triangle, EFH, has one angle greater than 90. It's obtuse. FHG, well, this is a 60 degree angle and this is a 60 degree angle. I don't know this angle. But I could use the same strategy as I did over there and say 60 plus 60 is 120. That's this angle plus this one. So if I take 180 and take that 120 degrees away, it leaves me 60 degrees for this third angle. Okay, well, if they're all three 60 degrees, they're equal angles. Equiangular would be my classification. Also, all of these angles, if they're all 60, are less than 90, so we can call it acute also. Equiangular is the more specific definition, so we would stick with that category. If you said acute, you did a nice job, but we could take it a step further. Now let's look at E to H to G. So now this is the whole large triangle here. And I see this is a 60-degree angle, this is a 30-degree angle, and here I see that little right angle symbol. That means this angle here at H, this bigger one, is 90 degrees. If I've got a 90-degree angle, I'm going to call it a right triangle. So that's it. As far as classifying triangles by angle measure, that's all we need to do. Now what if we want to classify them by side length? Now we're going to do a bit of the same sort of thing. We're classifying by side length. Remember, scalene has 0 sides congruent, isosceles has 2 sides congruent, and equilateral has 3 sides congruent. Think of that: equal, lateral means side. So let's look at triangle ABC over here, ABC, and I see these tick marks here, and this has a tick mark in 15, so I know this is also 15. Well, this is 15 also. Even though it didn't have a tick mark, it's still 15. So I've got 3 sides. They all equal 15. So for triangle ABC, I'm going to have to say equilateral. Now I'm going to look at triangle ACD. A to C to D. This one right here. And one side is 15, and one is 5, and one is 18. None are the same. So we're going to call that a scalene triangle with 0 sides congruent. Oops. Scalene. And finally, we're going to look at triangle ABD. A to B to D. Now, when you get a picture like this, where this is 15 and this is 5, I know I can find the length from B to D by just saying 15 plus 5 equals 20. So the length BD is 20, this is 18, this is 15. Again, no sides are the same, so this is triangle ABD is also a scalene triangle. Now, on your homework, you might get where you see these tick marks, and you know this is some expression and this is another one, and you could set them equal because of the tick marks. You know that if you've got 3 angles and they're all the same, they're all going to be 60 degrees. So use that information to do the algebra on your homework assignment also. Well, I hope this classification helps you. Read your book, watch your video examples, and you should be in great shape with this. Have a good day.